So to do the custom box decoration, it's relatively straightforward. So we're taking our main container here, and this is where we want to do our box decoration. So here we'll just say hex decoration. I want to have a primary color, which I just pulled from the image. And then I want to have a side length, which is going to be 20. So let's create this hex decoration class. We're going to need a decoration, and we're going to need a box painter. And once again, we want to have our primary colors and our side length. We need a method to return our box painter. And here's where all the heavy lifting is going to happen. This is similar to a custom painter, except you can see the signature of this method's a little bit different. So first, just to get something on the screen, let's just draw a rect. So I'm going to use my offset for the left and top. And the size we can get from this configuration object. Let's create a paint out of our main color as well. So you can see that that changed the color here, and just to show you, let's do a different color. So if I change this color, let's just add some green here. So you can see it redraws it. It's got this greenish color. So now we can implement our custom drawing, and we can do it inside of this hex painter class. But first, let's talk just a little bit about the anatomy of a hexagon. I have this diagram to kind of show that off. So we're going to be grabbing these top couple of colors. Let me just temporarily close my phone. Firstly, every angle in a hexagon is 120 degrees. That means that if you draw this triangle right here, let's show this. That means that if you draw this triangle right here, this angle right here is going to be 60, and this angle is going to be 30. And that's the label that you can see right here. And using SOHCAHTOA, you can get the length of this side right here, which is what we want. So let me just delete all this. So we want this side. So let's go ahead and do that, getting SOHCAHTOA. I will call that value half height. So it's going to equal our side length divided by 2, because as you can see, side length divided by 2, and divided by the tangent of 30 degrees, which is 0.523599 in radians. And 30 degrees, once again, is right here. So SOHCAHTOA, TOA is opposite over adjacent. So if I go ahead and do opposite over tangent, I get my adjacent value, which is this half height. Okay, now we can build up our hexagon. Or actually first, let's get the full height value. It'll be useful. That's just simply going to be half height times 2. All right, now we can build our points. So P1, I'm just going to have this one be 0, 0. So if this is 0, 0, that means this is our side length and then 0. P3 is equal to our side length plus half of our half height. So this is our half height. We just divide that by 2. And then for the y coordinate, it's just our half height. P4 is going to be our side length and then our full height. So you can see side length and then full height. And then P5 is just 0, full height. And then P6 is negative half of our half height and then our half height. and I'll come back to that in just a sec. So once again, P4 is our side length and our height, P5 is 0 and our height, and then P6 is negative half height divided by 2 and half height. Now, in order to draw these little tiny triangles, each of our hexes is actually broken up based on these 2 points right here and here. So in order to get those 2 points, I'm just going to divide my height by 3. That's not exactly what's happening here, but I'm just approximating here. So let's divide our height by 3, and then we can generate our triangles. I'll call these 2 points MP1, and then MP2 is side length divided by 2, height divided by 3, but times 2. Okay, cool. Now I want to get a bunch of triangles, and I'll represent my triangles as a list of offsets, and I want to map them to paint objects. So each triangle is just going to be one of these little guys. So our first one is just going to be P1, P2, and MP1. You can see that right here, P1, P2, MP1. And for the paint, I'm going to use our lerping trick. All right, great. So there's one of our triangles. I'm just going to copy over the rest of our triangles. Now I just need to iterate over this surface and draw these sets of triangles at different points along this grid. So I'm going to iterate over some y values and iterate over some x values. I'm going to keep track of the row because even rows are going to be indented, whereas odd rows are not going to be indented. I'm going to start at negative side length, just to make sure we cover the full surface. And I'll also add side length to the end. And for the y value, I'm going to add half height. And you can see the reason I do that in this pattern. So if you look at the upper left corner of this, and the upper left corner of this next row, there is a half height here. So that's why I'm adding half height to the y. Now for x, as I mentioned, if it's an even row, I want to add my side length plus half height divided by 2. I'll show you why I do that in just a sec. Let's finish this. And then similar to y, I'll just go up until the width, and I'll add a side length just for some buffer. And for the x, I'll add the height plus the side length. I'll show you where all of these values are coming from. So the first is this indent. This one's pretty clear. You can just see that if your first hexagon is here, then in the next row, your hexagon is going to be indented by this amount. Well, what is this amount? It's going to be the side length plus half of the height. So that's where this comes from. Side length plus half height divided by 2. Or I meant to say half of the height. And what do we add to the x? Well, that's just the height of a hexagon plus the side length. We can see where that comes from. So if we start here, we add a side length, and then we have to add a full height of a hexagon in order to get to our next hexagon. So all these values are just from this pattern, nothing too crazy here. Now inside here, just for all of our triangles, I just want to draw the path represented by that triangle. Okay, so this should simply draw the triangle at the proper offset. And you can see that we have something going on, but it looks totally wrong. So let's try and figure out what's going on here. Oh, so one thing I forgot to do is just increment our row after we're done with our x. So let's do that. Okay, so this looks a lot better. We can start to see that same pattern that we got in our image. Now what I want to do is just make sure we're not overdrawing, because there used to be that padding here and I basically got rid of that padding. So the way we can do that is to just clip our canvas. So we will save the current layer. We'll add a clip. And this can be our drawing area. And by the way, I want to get rid of this and also this. So we'll clip to our drawing area. And then when we're done drawing, we'll just restore our canvas. All right, great. So this is looking good, except we're not drawing down far enough. So let's increase the amount that we'll just set this to height times 2. We can go as far as we want. Since we're clipping, we don't have to worry about overdrawing. It's just, we run the risk of potentially drawing an extra row, but that's relatively cheap. Okay, so here we go. Here's the completed background. This is just a little custom drawing as a box decoration. It's a little bit different from custom painting, but it's super useful if you want to add custom decorations to your containers. All right, so now I'll go back to finishing up this game. I hope you enjoyed this little addendum, and I'll see you later.